me. Yeah. Okay, let's see. I'm going to share my screen. I just wanted to open something. Steepest descent. Let me. Looking for the slideshow in the wrong place for some reason. There we go. Okay, I'm going to share my screen. Okay, you should also see my screen. Just give me a shout there if you see it. Thank you. Let me also get that journal thing open. Right. How do you guys feel with it being the last day of LPR 381 in terms of class? Yeah, it's a milestone. Every time you finish something, it must feel very good. Yeah, I can imagine, yes. Let's hope you reach the milestone, but yeah, I'm gonna help you just practice the steepest ascent again with that question 1 and 2. And then we will go through some questions of the previous test. And then, yeah, then we'll be done. And tomorrow's the test. Crazy. And then Friday is a public holiday. And then you guys can spend some time on that project. And then you're done for the subject, of course. So, yeah, let's get to it. Let me see what's the question for question 1. Starting at point 1 and 1. Okay. So they tell us where to start, but before we get there, the first one is to prove that it has a maximum that we can search for. So we're going to first do the Hessian matrix question, and then we'll do the actual algorithm. All right. So I just want to rewrite the function in terms of x and y. No, Rishka, there's always an exam. So I'm hoping that's what I meant with I hope you'll finish the milestone, like that it's not gonna be a I see you again type of thing, you know. So yeah, obviously there's an exam, yes, sadly. But yeah, this next subject, I don't know, you guys have a next subject, I think, and then only exams. But I think there was like a week in between or something like that. I'm not sure your schedule, but yeah. A post will be made regarding that. I think still today a post will be made. So just as soon as someone sees it, let the others know. Yeah. Oh yeah, I am Miss Laub, sure no. Yeah. I am surprised they changed it. Right, but the review will be open today still. All right, cool. So let's get to it. Let's see how to tackle this one. And then we did golden section yesterday. If there's still time after review, we'll see if we can do another one. But yeah, I think with the machine learning question, it might take a while. Just something though, what topic has not been asked yet so far, except obviously this week's topics? What topic has not been asked yet except for this week? Yes, so take note that, right. Yes, guys, for the project, because the cutoff date is extended, don't worry if you submit after the 10th, as long as you submit before the extended date. Right, so don't feel like you'll be penalized for submitting late. We gave an extension, so you can submit as long as it's before the cutoff. Right. But be wary, don't have any excuses for not submitting on time, even though there's an extension already, because that will not be considered. So please, before the cutoff, please cut off. Right, but yes, I'm on traveling, so because it was not asked, you can expect it definitely now or in the exam, right? So please prepare for traveling as well. You already know all the topics is possible to be in the summative, but obviously because traveling was not asked, I would suggest that you recap and revisit that more in detail. And then obviously this week's topics in a lot of detail, and then obviously anything else can come in. It's just mostly going to be focusing on this week and what was not asked, but whatever is extra will then just fill it up, so to speak. All right. I'm not sure, Amandra. As far as I'm aware, it's 2 hours, but I'm not 100% sure. Right. As far as I know, it's 2 hours, but I don't know the final decision yet. I'm not the one who said the test, so I can't tell you what's the final decision. Right. Cool. So let's get started. However, I can maybe just give you a fair warning. Usually for exams, we tend to make it longer because, I mean, you saw these topics are quite large questions. So do expect definitely the exam to be longer. We won't do 4 hours, but I'm just saying, like, you can expect a 3 hour or a 2.5. Right, because it's more difficult to fit more topics in. But we'll see how that goes. Okay, so this one, let's see how to get the Hessian matrix again. So the Hessian matrix is to check whether you have a max or a min that you can search for. So we're going to start with that. So first partial derivatives is where we start. So we're going to get our first partial derivative in terms of x, partial, meaning part. Then our second part is going to be in terms of y. So we're first going to focus on x. So remember that if there's a plus or a minus in the middle, it splits them into separate terms. With differentiation, you then see them as separate terms. Then in the first term that we have here, it does have x in it, so we can derive that one. Okay, so we derive x, it becomes x to the power of 0 because you multiply the 1 in front, subtract 1 from the power. The y is seen as a coefficient because you are deriving in terms of x. A constant because it has no x there. So constants we know fall away when you derive. The next one does have an x, so we have to derive that. Take the 2, multiply in front, it becomes minus 2. Then you subtract 1 from the power. The next one, next term, doesn't have an x in it, so it's seen as a constant, so it falls away. So in the end, our first partial derivative is going to be, I'll write it in terms of alphabetical order, minus 2x plus y, because that's just a 1 there. Right, and this is to make life easier later on. Put it in alphabetical order, or x1, x2, x3. It's just to make life easier later. Okay, then in terms of y, so that was in terms of x there. Now you're going to look at it in terms of y. So in terms of y, the first term does have a y, so we can derive that. Okay, so we derive the y, it becomes y to the power of 0. The x is seen as a coefficient, so it just comes along. Then the next one, it does have a y, so we can derive that. Be careful for this. It doesn't just fall away, please. This becomes y to the power of 0, which means it's a 1. Right. Next one doesn't have a y, so that term is seen as a constant, so that's plus 0. And then the next one has a y, so we derive that. It becomes minus 2y to the power of 1. So our first derivative in terms of y is going to be x minus 2y plus 1. So I'm just writing it alphabetically and then my constant last, just to help me when we continue with the algorithm. It saves some small mistakes. It helps to avoid some mistakes. All right, so we are ready to do the second partial derivatives. So we're now going to do our second partial derivatives. So we're going to have an xx, we're going to have an xy in that order. Then we're going to have yx, and then we're going to have yy. Just to remind you, when you do your matrix, it's like this. The first variable first, and then the second variable, and then you'll have your xx, your xy. It always goes row by column because it's a matrix. All right, now let's see how do we get that. So let's first start with our first one. So this comes from our first derivative of x. This one also. So let's start with those. So this one, it comes from the first derivative in terms of x, and now I'm deriving x again. So in the first term that I have, it has x, so I derive that. It becomes minus 2, x to the power of 0, but yeah, you can just write minus 2 then. The next term does not have x, so we see a constant, so you can write a constant y. So the value is just going to be minus 2. Right, next one, let's see. So the next one, we're still busy with the first derivative of x, but now we're looking at y. So from the first derivative of x, the first term does not have a y, so nothing. The second term does have a y. If you derive that, it's just going to be a 1. So you put your 1. Now you go to the next one. So that's saying it comes from the first derivative of y. Then we're now going to look at x first. So from our first derivative of y, we look at x. So the first one is x. I can derive that. That becomes a 1. The next two, the whole plus 0, just to keep track. And then that's going to give us a value of 1. Then the last one is the y. So first derivative of y, we're looking at the first term. That's an x, so no, that's a constant. The second term is going to be having a y. So then we derive that, it becomes minus 2. And the third term is just a constant, so plus a 0 there. So our value is minus 2. So we found our Hessian matrix. Hessian matrix ready. All right, now we have to find the derivative of that. So remember, you can just go onto Excel, just make a new sheet. So you go into Excel, you type your Hessian matrix. If there's no variables, otherwise you'll have to do it the long way. So we find the determinant, so M determinant, highlight, and then we get our value of 3. Okay, so we can say that the determinant of the Hessian matrix is equals to 3. If you were to do it the long way, it's simply top times bottom left times bottom right. So that would be these two that you multiply first with a minus in the middle and then the other two. So that would give you 4 minus 1, which is still 3. All right. Now we say, but what does that mean? So if your Hessian matrix determinant is greater than 0, it is not a saddle point, meaning it can be giving you a local min or a local max, depending on whether it's convex or concave. Right, so what's the next check? So we now take our main diagonals. So our main diagonals are these, the XX and the YY and the ZZ and the KK, whatever, as long as it's the same letter. So we're working with our main diagonals of -2 and -2. So they're both the same, meaning we can conclude something. What are we concluding? That it's less than 0. If it's equals to 0, you can't conclude anything. But less than 0, we know, okay, that means that it is, remember, negative being sad face. Even though that's not what the function looks like, it's just a quick check. Sad face, so that's going to give us a maximum that we can work with. So we proved that there is a local max. We don't know if it's a global, we just know that there is a maximum that we can search for. Right. So we checked. Question 1 done. Just like that. Now we get to the long question. So solving. So we're now actually going to solve this. So question 2. So it's still the same function. We are just actually going to look for the maximum because we proved there is a maximum to look for. So we're going to look for it. In a test, we will probably specify what you should look for to avoid you building on the wrong answer previously. Right, so we will try, unless it's not too big of a question, then we won't do that. But in a lot of cases, we try to say, okay, if you start searching from here, search for X. If you start searching from here, just to avoid building on the wrong answer before. All right, but let's see, how do we go with this? So they say we need to start at our initial guess of 1 and 1. Now, please remember, golden section search was one variable. So that 1 and 1 would mean that it's X for both because you only have one variable. It's just two coordinates for X. So X1 and X2, or we worked with lower and upper, and then you had to have X1 and X2 in between. Whereas this is multivariables. So if you've got multivariables, those refer to the actual variable coordinates. So this is going to be our X, and that's going to be our Y. If you had a Z, you'll have another one there with another value. All right. Just refers to the initial value that you're starting with for that variable. All right, now we go and we say, what do we start with? So we first substitute it into a function to see what is our value, our Z value, just to keep track. So you're literally substituting 1 into X and 1 into Y, literally, quite literally. Okay, so that's going to be 1 plus 1 minus 1 minus 1. So we get a 0. Not a problem. It doesn't mean our gradient is 0. No, this is our Z value. Okay. Now we can start following the steps. So our first step is to find the gradient of a function at that specific point. So I normally do it like this to say at that point. We do have the first partial derivatives already, so I'm going to copy that down. So I'm going to literally copy the first partial derivatives. Only the first, because the second is just to check. The first is what you need to get the gradient. The first derivatives are for the gradient. So I'm going to copy that. First derivative of x minus 2x plus y. First derivative of y equals x minus 2y plus 1. So I'm copying that down. So first derivative in terms of x is equals to minus 2x plus y. Write it alphabetically to save you trouble later on. Well, very soon. And that's our first derivative of y. So now we're going to say, okay, I need to substitute this point to see the gradient at this point. So to get our I value, we substitute into the first derivative of x. What do we substitute? 1 and 1. 1 for x and 1 for y. So even though there's an x and a y, you just go and say, what is the value of x that I'm substituting? That's a 1. What is the value of y that I'm substituting? That's a 1. And I can calculate my I value. So that's minus 2 plus 1. So that's going to be minus 1i, or just minus I. Next one, j, we get from the next derivative. So the second variable, that's going to be then substituting. So first x. What's the x value? It's a 1. Minus 2 times y. What's the y value? It's a 1 plus 1. So 1 minus 2 is minus 1 plus 1. That's going to give us a 0j. One of the axis values is actually a value, not just 0. So it is not a gradient of just 0. It does actually go in a direction. So we specify that our gradient of our function at 1 and 1 is equals to minus I. You could have just said minus I, but obviously on assessment Q, you would have to fill in then the 0j there. Right, never leave a blank. Okay, we've got a gradient to work with. So now our next step is to find h. So how far can this specific gradient be followed before it changes? So we need to find now our h value. So our h value is that whole formula where we say, okay, to take one step, we start right now from the initial because we haven't done anything yet. So we start at the initial vector and we add the multiplication of our step size in terms of the gradient at that specific step, if I can say it like that. Right, so that's your formula. Now we go and we say, okay, how do I substitute that in? Okay, so xi was our initial coordinates, so x1 and y1. H we don't know yet. And then we substitute our delta f. So remember, the first variable is for the x, second variable is for the y. Now we do that whole thing where we multiply the h in, so it's literally h times that and that. So you're left with minus 1h, 0h. Now something is 0, I mean, there's no need to write it at all. You just go and say 0 there. It's nothing, right? So no h. There's no h. Okay, how do I combine? So remember, we had to do that whole top values are specifically for x. So it's like adding like terms. Bottom values are specifically for y, or x1 and x2. So we're going to have our top as 1 minus h, and our bottom is simply just 1. So that's what we need to use in terms of x and y. All right, now the long process is actually substituting that back into your original so that we can actually solve for h. So you're substituting into x, you're substituting 1 minus h. Into y, you're substituting 1. So I'm just going to rewrite the equation here and erase it again, but just so we can see what are we substituting. So I'm substituting into x, 1 minus h, into y, just 1, into y, just 1, into x, 1 minus h, and that's a square, and into y, just a 1. So I'm just substituting into our original function. Right, let's see. So you can first multiply everything out and then derive, or you can just multiply and sort out the brackets to the power of 1 and then directly do the derivative. It's up to you how you want to do this. You'll see in my Excel sheet I multiplied out, but right now I'm going to use the chain rule. So I'm going to first sort out by multiplying my brackets to the power of 1 there, which is going to be just the same thing, 1 minus h. I still have that plus 1 there. Then I leave my brackets to higher powers because I'm going to use the chain rule, and then that is going to be a minus 1. So this is now our function in terms of g of h, a new function in terms of h. Now I'm going to derive that. So I'm going to say find the derivative of that directly. So I'm not going to multiply everything out. So I say, okay, how do we do that? So first things first, if I look at constant values, we know that they will simply fall away or become 0. So that's going to be just a 0. That one's going to be 0, 0. Right. Now for the next one, minus h, if I derive that, because it is in terms of h, if I derive that, take the power of 1, multiply in front, it becomes minus 1, subtract 1 from the power, but you already know by now that that just means the same thing, right? But if you want to write it out for now, you're more than welcome to, so that you can remember, oh, that's still the same as 1. Next one, constant, okay, never mind. Now the next one of the brackets, so I'm going to go and take this here just to show you again. So that's going to be what I take to do the chain rule. So first find the derivative of the inside. So if I derive the inside, the 1 is a constant, that becomes 0. The minus h becomes minus 1, h to the power of 0, which is minus 1. I have to multiply that with, then I do the next, right? So let me just do that at the bottom. So I take my power, I multiply in front, it becomes minus 2. The bracket stays the same, and then I multiply it with that derivative of the inside. Right, so I do the outside first by saying minus 2 times minus 1 is going to give me a positive 2, and then 1 minus h there. Then the next one was just a constant that falls away. Right, let's simplify it a bit, because obviously we'll expect the simplified version of this. So we've got there a minus 1. Remember, that's just minus 1. Multiply your bracket, so that's plus 2 and minus 2h. So then our final answer for our first derivative would be minus 1 plus 2 is positive 1, and then minus 2h. Who remembers what do we do after this? Like, what do I do with that to get h? What do we actually do? Very good. We set it equals to 0 to take the maximum step size. Remember, if you want to take the max, you find the first derivative and you set it equals to 0. So that's what we're doing. We're going to set it equals to 0 after we found the first derivative, which we already did. Now we're just setting it equals 0. Take the 1 over, it becomes minus 1. divide by -2 on both sides, and then you're going to have h as 1/2. So a half. Once you get h, you put it back into where you started with h to find x and y. So you're trying to find a new coordinate because you want to move. So we now go into our previously set up h, and we now substitute this by saying h is a half. And then you can tell me what's 1 minus a half. Just a half, and that's 1. So we've got a new coordinate. Now we repeat. So that was iteration 1. We're now going to iteration 2. So the initial plus 2 steps. So now we go and we say what is f of this to see what's happening to our function. So you're literally substituting it back into your function again, that whole xy plus y minus x squared minus y squared. So into x, I substitute a half. Into y, I substitute 1. X, I substitute a half. Into y, I substitute a 1. And then we calculate. It'll be a half plus 1 minus 1/4 minus 1. I get 1/4. So 1/4 is 0.25. So if you wanted to just check if it's actually better, from our first f or z value, we had a value of 0. We're trying to maximize. So it's going up. Great. Right, we want to maximize so it is actually moving in the direction that we want it to move. So that is really good. Right, now we go on. So, okay, we have a new step. So let's substitute. We now go and take this new coordinate, and we just literally repeat. So we need to get our gradient again. So what do we use? We use our original first derivative. So I'll just rewrite it again. That was minus 2x plus y. That was x minus 2y plus 1. I now have a new coordinate that I need to substitute. So into x, I now substitute a half there, and into y, I substitute a 1. Into x a half, and to y a 1. So that's basically what we're doing. I'll just rewrite it so that if you were making notes, it's easy to just write down. So that would be a half minus 2 times 1 plus 1. Don't forget that 1. So minus 2 times a half is minus 1 plus 1 is 0. Then a half minus 2 plus 1. So I'll do minus 2 plus 1 is minus 1 plus a half. It's going to be minus a half. So we have, let me just check. Yes, minus a half j. So our gradient of our function at a half and 1 is equals to 0I minus a half j. So it still has direction. It's not 0 and 0 and 0. It does actually have a direction. So we cannot stop. We have to go on. Even though, I hope you notice that even though our j value is a negative, it doesn't mean you're necessarily going downwards. It's purely based off of the fact that you have negatives in the function itself. So it doesn't mean it's doing the opposite effect. So don't look at the gradient to say whether you're going up or down. The gradient is just giving you a direction. Then you can use your step size to estimate if it's going up or down. But the best way to check is substituting into your function and seeing whether it increases or decreases. That's the best. Right, so let's see. We now go and say, but what is H? What is H? So now to get H, I do that whole, okay, I'm trying to take the second step. So I'm now moving from the previous step, which was +1. And I do that whole H times the gradient of the function at that point. So that's going to be now the step that we have. So I'm just going to write it down from there. So 1/2 and 1 plus H, which we don't know yet. And then now our gradient is 0 and minus 1/2. And we're ready to sort that out. So we're going to multiply our H in. So 1/2, 1 plus nothing. 0 times anything is literally just 0. Don't write a 0H there for me. It will be pointless. Just 0. Then H times -1/2 would be -1/2 H. Caitlin, you won't look in your gradient. Remember, I showed you now that it does not necessarily mean that you go in the wrong direction, because you still have your I that's positive there. So you have multiple variables, which makes it harder to know whether it's actually going in the correct way, unless if you literally sketch it. So don't look at your gradient, but look at your step size. Your step size would give you some kind of indication. It's not a good way to check. It's just a quick check. However, you would normally go and check your function value, meaning there where you substitute your coordinate and you check what's your function value. If it increases, you know it's going max. If it decreases, min. If you see that it's going the wrong way, it could be that you made a mistake, or it could mean that it's only going to go to the correct way later. So sadly, you can't really take it as a check in a test, because we could have let you start somewhere where you're first going to go in the wrong direction and later on go in the correct direction. So you just continue searching for the amount of iteration we ask. Right. Sadly, you can't really check. Yeah, that's a bit sad, but yeah. But if you, let's say, get a question looking for a maximum, and you, in the previous question, check that there is a maximum, so you know for sure that there should be a maximum, and I give you a starting point. So I'm asking for a max. Previously, you know it's a max, so it's dead on, it must be a max. And you start doing your iterations. After like iteration 3, you're still going min. Maybe something's wrong. Like that sounds weird, right? So then you can basically tell you that no, why am I just going minimum, but they want a max, like something's not okay. Obviously, in real life, you would then go and look for a different search initial start, right? So then you'll start somewhere else, and you'll then search from there to try and find a max instead of a min, because this is just a numeric search. So you continue searching until you find what you need. But yeah, in a test purposes, you stick with the initial guess that's given. You don't try and search somewhere else, purely because if you have to guess the initial, all of you will have different values, like all of you. So it would quite be pointless. Okay, so you stick to the initial guess that we give. Right. Imagine. Yeah, you only know when you get your results. Sad. But yeah, if your vector gradient is 0, 0, even if you had a k with a third variable, if there's just zeros throughout for all of them, then you definitely know it's not going to move. you are at a gradient of 0 because everything is 0. As soon as something is not 0, then you know, okay, so it has a direction. It's just for one of the axis values will not change. Right. So let's see, we now go and combine them. So that's our x, and the other one is going to be our y value, and we combine them. Caitlin, who knows now when to stop. That's a classic. So we go on, we say this is now going to be just a half on top. Just remember, we multiplied our h in already. So this is a half on top, and at the bottom is 1 minus a half h. So now for the long work again, we substitute it into our function. So into x, we substitute a half. Into y, we substitute 1 minus a half h. So I'll just write the function here on top. All of this. Okay, so we're ready to continue. So I substitute that in. Am I going to have space? We'll see. So x is just a half. Y is 1 minus a half h. Y is 1 minus a half h minus x, which is a half, minus 1 minus a half h, and that's squared. Right, so now we can sort out the brackets to the power of 1, multiply them out first. So I'm going to first start with these. This is just brackets to the power of 1, so you can rewrite it without brackets. So let's see what we get. A half times 1 is going to be a half. A half times minus a half is minus a quarter h. Then those brackets just fall away. Then minus and a half to the power of 2 is going to become 1 over 4. Use your calculator, please. And then the last bracket I'm going to leave as is because I don't want to struggle multiplying it out. I want to do the chain rule. It's up to you. If you want to multiply it out, please do. Right. So that's my g of h. Now I'm going to find the derivative immediately. So our first one is a constant. It literally becomes 0. The next one in terms of h, so I can derive that. It becomes just minus a quarter because it's h to the power of 1, so it becomes h to the power of 0. The next one is a constant, so it becomes 0. The next one is an h, so it's just going to be the value that's the coefficient. The next one is a constant, so that becomes 0. Doesn't matter if it's plus or minus, just 0. But now for that bracket there, so the derivative of the inside, constant becomes 0. Something with an h to the power of 1 just becomes that coefficient. Then I do that whole take the power times in front, becomes minus 2. Bracket stays the same, times with that derivative. Okay, so this leaves me with minus 2 times 1 minus a half h times, not just minus a half, times minus a half. So if I quickly multiply that minus 2 and this minus a half, I'm going to get positive 1. So I'm just going to rewrite the top quickly, minus a quarter minus a half. Then I'm going to have a positive 1 there that I have to multiply into my brackets. So my brackets are going to stay the same. You can already go and say what's minus a quarter minus a half. I'm just going to do it at the end. These steps will not be asked. It's literally a final answer there that we are going to look for. So that's plus 1 and minus a half h. So now we can do our like terms. So it's going to be minus a half h. And then minus a half plus 1 is positive a half minus a quarter. And that's positive Let me just double check. Minus quarter, minus a half. And then that's going to be positive 1, so plus quarter. A plus a quarter. And we set it equals to 0 like we always do. So we go and take our g first derivative and set it equals 0. So that's going to be take the quarter over, it becomes minus a quarter, divide by negative a half on both sides. So h is going to be negative half times positive 2. That gives me still a positive half there. Negative 2, yeah. That's positive a half, so I can substitute back. So I'm now going back here to that and substituting it back in there. So you'll see every time I use the previous, not the initial. So it's always, as soon as you take a step, you're taking a step from the next step, and then from there next, from there next. It's almost like your branch and bound. You take steps, but you don't use the initial. You build on the previous. All right, so let's substitute that in. So it was a half, and at the bottom it's 1 minus a half h. So now I can substitute that h because this was h. So it gives me my new coordinate, meaning we moved to the half stays a half. 1 minus 1 over 4 is 3 over 4. So we have a new coordinate. Right, so we want to check what happened in terms of our function. So in terms of our function, we substitute. So I'm just going to write the function here at the bottom. And we substitute. Okay, so I want you to do this with me so that I can double check the values. So it's going to be a half, we substitute into x. Into y, we substitute this one, plus y minus x squared minus y squared. So quickly calculate that and let me know what answer do you get. So I'm going to give you just a minute or check your notes. I agree, Henry. I also get the same. 5 over 16. If they asked you to round, let's say 4 significant figures, it would be approximately 0.3125. Right, 4 significant figures. The 0 in the front is not significant, so you don't count it. You still write it. No problem, I'm going to go up anyway. So that's now our z value, 0.3125. So from our first one, our first iteration, we had our function at 0. Then I'm going to scroll a bit down just in case you want to take that on Monday. And then to the next part of H. I hope that's okay. Awesome, pleasure. Then our function value became 0.25, so it increased. Then we go on, and it increases even more. So from 0.25, it increases more with these coordinates. So we know we're doing the right thing by starting at that initial. Okay, so that's iteration 2. Was that 2? Yeah. Just want to make sure. Iteration 2. Now we go to iteration 3. I'm just going to do 3 and then I can do 4 as well. But then 5 and 6, I'll be like, yeah, go look at the answers and I'll show you the answers, right? Yeah, hey, it could be worse. They could have asked for 10, hey? But yeah, the more I do now, the more hopefully it will sink in and you will pick up things and hopefully remember. But yeah, I'm not going to go up until 6 because then we'll sit on the same thing. So I'll then just show you the answers there. All right. So it just repeats. Okay, but it does help to see if you made a mistake. So I'm going to go up until 4 just to help you double check. Right, so let's see. This one is now a half and 3/4. So when we do that whole x I plus 3, because we're doing iteration 3, oh, sorry. I know this was annoying me. Okay, so I plus 3 equals going from I plus 2, and you're doing the H delta F, so we need the delta F in order to continue. Right, so I just didn't write that first, but we're going to still need it. So I'm going to go and say my first derivative of x. What was that again? Let me see. That was minus 2x plus h. And this one is going to be x minus 2y plus 1. So we're going to quickly substitute in there. So into x, you're substituting a half. And into y, you're substituting 3/4 there. So x a half, and into y, 3/4. Let me see. So that's going to be minus 1 plus 3/4. Is that -1/4? I think so. -1/4. I just want to double check that so that I don't lie to myself there. So that's literally minus 1 plus 3/4. Yeah. Okay, then we've got a half minus 2 times 3/4. So you've got a 6/4 there plus 1. I get a 0. Right. No, I do not know. A post will be made about that still today somewhere. So just check. Thank you, Danila. You were at the same speed as me there. Right. I'm a bit slow today. I'm sorry. Then I check. We do the whole substitution. So from the previous point, which was now, yeah, let's blame it on the internet. Yes, thank you. In the end, we do. This one and this one. So let me just remove that. There we go. Okay, substitute. So we need to multiply our h in. So that's going to be, I'm going to skip a step. I'm going to say it's a half minus 1/4 h. And at the bottom, it's simply 3/4. So if they substitute it now back in, let me just go write down what was the function. There we go. Now we can substitute this in. So into x, it's going to be a half minus 1 over 4h. Into y, don't know why I did that, 3 over 4. So we go substitute into x, 1 over 2 minus a quarter h. Into y, 3 over 4. Into y, 3 over 4. Into x, a half minus 1 over 4 h squared minus 3 over 4 squared. So I'm first multiplying my brackets to the power of 1 and sorting out things like that doesn't have a variable in, and that one. So I'm going to be left with a half times 3 over 4, which is going to be 3 over 8. And then minus a quarter times 3 over 4 is going to be minus 3 over 16. H. That's just going to be plus 3 over 4. Then we leave this bracket so that we can do the chain rule. Although I can probably multiply this one out as well. Why not? So it's going to be 2 brackets. Maybe write it at the bottom so that we have space. So then it's going to be minus this to the power of 2, so twice. And minus 3 over 4 squared is going to be 9 over 16, square both top and bottom. Right, so let me sort out these brackets. So we first do the brackets first, so half and a half. I'm going to give you 1 over 4. Then a half and negative a quarter, that's going to be negative 1 over 8h. That's also going to give you negative 1 over 8h. And that's going to give you positive 1 over 16h squared. Then obviously that's just for those brackets. That's just for this if you wanted to multiply it out. You can do chain rule, but you're more than welcome to multiply it out. So I just want to rewrite everything I do have. So I'm going to ask you help now to make sure that we don't have any mistakes. Just be careful for this. Remember there was a minus in front of the bracket, so everything in here red is going to be in brackets with a minus in front. Okay, we have to multiply our minus inside as well to literally everything. So let's see. Minus a quarter plus 1 over, we can already do the, that's 1 over 8. 1 over 8 plus 1 over 8, then I'll just make it a minus. So that's 1 over 4, so minus 1 over 4. So I'm just going to immediately do that, and then it becomes a positive 1 over 4h. Yeah, it is. But it's just, yeah, if you forget how it works and you're not sure, then rather take this, because this has been ingrained, I think, in your brain by now. But yeah, my suggestion would always be to do them both when you have time. So when you can come back to maybe multiplication of brackets, just to make sure that you didn't make a mistake and you're losing the rest of the marks just on a small minus or something, right? So if you have time, please do that. So let's see, that's going to be the minus quarter plus quarter. Then that's going to be minus 1 over 16h squared. And then we are left with that minus 9 there. Right, let's see. So these do not technically have to do because we still need to derive, but we'll do it. Does not hurt. What do you guys get for the constant value? I'm also quickly doing that one. If you multiply out. I'm just going to highlight the rest so long. It's going to be for H. So you can just check my value. I get 5/16 there. Then for our H, 1/16 there for the H. Then that one is purely going to be minus 1/16 H squared. So let's do this. That's for that one. That was for that one. And then that one. Right, so if you were multiplying, that would be it. But you still need to find the first derivative. Right, so we need to get the max step size. So first derivative and then equals to 0. So first derivative, a constant, becomes just 0. If it only has something to the power of 1, it's purely going to be the coefficient. Then the minus 1/16 is going to be times 2, so that's minus 1/8, and then subtract 1 from the power. So that would be your first derivative. Just scroll down. So let me just write it like this. First derivative is equals to minus 1/8h plus 1/16. Now we can set it equals to 0. So you'll take your 1/16 over. It becomes minus 1/16. Remember, we work with fractions. If we ask you to fill in with a decimal, sure. And if, let's say, the value is so small, there should be some kind of instruction saying how to round. Because sometimes we find values that are so small or so infinite that a fraction will not be possible. Right, so then you write it as a decimal. You have no choice. Okay, so let's see. That is now divided by minus 1/8 on both sides. Let's see what we get. So minus 1/16 times negative 8. So it's going to be positive 8/16, which is 1/2. So H is still 1/2, giving us some kind of indication it's increasing, although I said don't take that as your only check. So it's some indication, and we can now substitute back our H. Right, so we go back to the previous. So just be careful not to go too far. There's my previous, this one. So I'm going to go substitute it in there. So H now becomes a half again. Guys, not always a half, it's just this example. So don't go in a test and put a half into H. I mean, you're trying to solve H. Then I'll write feedback for you to say, don't be silly. No, I'm just kidding. Right, so that's going to be a half minus a quarter times a half in 3/4. So to get our new coordinate, we're going to have a half minus 1/8. So that's going to be 3/8. And the 3/4 stays 3/4. Right, so we're done for iteration 3. We can go to iteration 4. Now before we do that, let's check what's our function value to see if we didn't go past the maximum already. Because if it now starts to decrease, you can conclude that the previous one could have been the maximum already. So we go and say, substitute that in. So remember our function is xy. Let me just write it down again. Xy plus y minus x squared minus y squared. So into x, it becomes 3 over 8. Into y, 3 over 4 plus y minus x squared minus y squared. What did you guys get here? Iteration 3 going to 4. What did I get? Let me see. Is there anyone who got 21 over 64? Is there anyone who made no mistakes up until now? Would be quite impressive. Yay! Okay, that's impressive. You made no mistakes up until now. Fair warning though, in previous tests that we had set up, the fractions are sometimes worse than this. Just a fair warning. So keep on using fractions and do this example again later on to practice, to just get the hang of how to divide by fractions, how to multiply, how to do this. All right. So this is a very good example. Okay, let's see. So I agree with that value, and that's approximately, if you round to 4 significant figures, let me see, 21 over 64 is 0.328125. So we round to 4 significant figures, it's going to be 3281. Right, just go make sure you go check, does a 0 in between significant figures also count? And does a 0 in front of the significant figures count? Is it a significant figure? When is it a significant figure? Because the whole idea with it is to count only significant figures, and a 0 is sometimes a significant figure. But in front, no, it's not significant. In front of numbers that are not 0, it is not significant. So you don't count it, you write it. Yeah, Daniela, that was a bit I was also like, at least you're answering me. So it's not just me today. Your internet is feeling my vibes. I'll try to pump myself up during the break so that your internet also gets a bit of a hype or something. We're going to stand outside going, more energy, more energy. Hey, at least you're learning a new skill. You put that on your CV. You'd be like, I can decipher AI speech. Yeah, I can find a positive in anything. Don't try me. I actually trust and believed you there, Danilo. Don't worry. I'm gonna miss you guys. Yeah, Henry, that's how you endure it, hey? Like you just have to keep on seeing the positive in everything, then you can endure anything. Sadly, saying that with a tear in my eye, you know. No, I'm just kidding. Let's see. So that's better. That's better. Let me highlight that one. I'll maybe pop in with some positive vibes there. If you guys feel like you're low, like I'll come and join the chat, and be like, oh, you can do this. But yeah, at least some of you enjoy programming more, so it doesn't matter who teaches the subject, you'll be okay. You guys are fun. Okay, let me go on. So iteration 4, right? So I'm going to quickly run through iteration 4, but just the start of it. So you'll see the fractions gets quite small, but you still do the same thing. It's still the same repeating steps, repeating. So we go on and we say, all right, I now have my new coordinates. I can do the same again, but for iteration 4. So from here, we go and we say, okay, I have to get my bearings now again. Let me just see where we were. Okay, I got this. All right, so we do our f first derivative for both variables. I think we can go check what was our first derivative. It was minus 2x plus y. Another one was x minus 2y plus 1. So guys, you have to be like on point with the first partial derivatives, because I mean, you see how you're constantly using that. So please be on point with your first partial, meaning double check that like 3-4 times. Hey, like don't have a sign mistake, or don't forget to put a +1 because you assume it's a constant, but no, it's not. Right, so double check that like 3 times because you're reusing it over and over. Right, what are the values now? So x is 3/8, y is 3/4. So I'm substituting my new coordinate. Okay, ready, let's see. Okay, so this time I'm not gonna read it to you. I'm just gonna get the answers there. So I got for this one a 0i. You can double check and let me know if you don't, then I can also double check. But I got 0i, and then for the next one, I got -1/8j. Right. So it's literally substituting it in, and then that's the answer. Those are the answers. Let me know if you want me to double check them. Otherwise, I'm going to assume you got the same. Or you're just looking. But try it on your own, hey? I mean, it's too late to realize in a test that you don't know how to put brackets in your calculator or something, It sounds silly, but yeah, that happens. Right. Will it always be that either the I or the J is going to be? Yeah, I see Evan also answered you. Unfortunately not, no. We are lucky with this one, to be honest. So in a lot of cases, both of them will have values. It's just this function worked very nicely. That's why I showed you the chain rule, because I saw in previous tests that there's a lot of them where both are actually values, and then doing something to above 2 and another something to above 2, it's quite hard to multiply those brackets. So that's why I decided to show you the chain rule again, so that you have a shortcut and you can compare it to that. Right. But yeah, unfortunately not, no. And unfortunately, probably not that lucky. It's hard to get an equation that works out so perfectly. So I doubt it. Sorry, Anika. I doubt it. But if you do, and you're that lucky, then we jump up and down, hey? Okay, let me see. Where were we? All right, taking that, we do that whole x, we're doing the 4th step. So it comes from the 3rd step plus our h, no delta f. Then this comes from the 3/8, 3/4, and are now 0 and minus 1/8. There we go. Probably. Let's see. That gives us 3/8 and 3/4 minus 1/8h. There we go. For the long work, you would now literally go and substitute 3/8 into x, and the other one is going to be literally all of that. So let me just rewrite that whole thing again. I think it was plus y minus x squared minus y squared. So please have some paper ready so that you can write it down somewhere and just every time relook. I won't suggest you rewriting it every time, because then you write it down wrong once and then bam, the rest is wrong. So have it written somewhere and then keep on checking that. And let me see what I did here. Right. Okay, let's see. X is 3/8. Y is all of that. All of that. Minus x squared. Yeah, imagine that. Yeah, that's terrible. And I can tell you it has happened to people in the past. Luckily, some people were very lucky to get some values still correct, but yeah, sadly, you can't get, like, first mistake. It's probably going to mean that, yeah, there's no chance of getting full marks then, and you don't even know it. So sad. But yeah, let's hope it doesn't happen. Be positive. Be very positive. All right. Okay, 3/8 times 3/4, so that's going to be 9/8. So I got a 9/32 for that one. Then a 3/8 times minus 1/8h. It's going to be a negative 3/64h. That's what I got for that one. Then the next bracket I'm just going to rewrite. Right. Minus outside, then it's going to be 3/8 squared. So I got a 9/64, which makes sense. Then the next one, I'm going to do chain rule because I do not want to waste any more time. Right, so that's our g of h. So I'm now going to do the g prime of h, meaning find the derivative. So we can immediately say everything that is a constant will disappear. So I'm not even going to write it this time. They will disappear. Everything with just an h will just be the coefficient. Right. So I can immediately go and say that's going to be minus 3/64 and minus 1/8. Now I'm going to look at, so just to make it clear, that's for that. Right. Then let's now look at the other one. So this one, right? So for that one, what's the derivative of the inside? So a constant becomes 0, and the h, you get the coefficient of that. So it's literally the coefficient. You can write it as h to the power 0, but that's quite pointless. It's just going to be the 1 there. Right, then you do the whole times the 2 in front. It's a minus 2. Brackets stay the same. Subtract 1 from the power times the derivative of the inside. Be careful not to actually go and subtract. I mean, it's actually multiplying the derivative of the inside. Even though it's a minus, don't let it confuse you. Right, so there I go. I'm going to say that is going to give me, I think it was minus 11/64, but we'll see. Then we multiply, so that was now for all of this. So now we can go and multiply the front value. So that's going to be minus 2 times minus 1/8 gives me a positive 2/8, which is the same as 1/4. So I'm just taking that one times that one, just to help me not to subtract by accident. Then it's 3 over 4 minus 1 over 8. H. Scroll down a bit. And now I can multiply this 1 over 4 inside. So I'm going to have, so 1 over 4 times 3 over 4 is going to be 3 over 16. Then a negative. Then 1 over 8 times 4 is 32. H. Then I can add the last two. Remember, this is already the derivative. Add the last two. So my answer I got was 1 over 64 minus 1 over 32 H. And H is again a half. So you would do that whole, set it equals to 0, take the 1 on the other side, it becomes negative 1 over 64. You literally use your calculator and you divide whatever is in front of H. So you'll see H is again a half. Right, we're going to substitute back. So just going back here to show you there was the one that I had now previously. So I substitute my H in there. So it's going to be 3 over 8 stays 3 over 8. 3 over 4 minus 1 over 8 times a half. So let's see what our new coordinate is at iteration, after iteration 4. So that's going to be still 3 over 8 and then 11 over 16. Then let's get the function value. Let's see what you guys got. Let's see if you, whoever got this far, let's see. What did you get? Three over 8, 11 over 16, awesome. And then your Z value? Oh, limited time. What's your Z value? Yes. Well done. For those of you who got it, well done. If you didn't, it's just going to take some practice, but it means that you have to go practice. Right. Okay, let's see. 85 over 256. So that gives me approximately, rounding to 4 significant figures. It's an infinite value, guys, meaning it goes on and on. So we are going to write the 0. So 0. So we see it as significant because it's in between other significant values. So we do need to count it, and we do also need to write it because it did actually continue. Be positive, Ivan. Be positive. We are climbing. We're taking the stairway. All right. So that's even better than before. It's a very slow upwards trend because from the previous one, it was 0.3281. Now it's 0.3320. So it's climbing just so slowly. So basically, if you start picking this up, you can already conclude what the value is. You can have an estimation, right? So you could have continued. I mean, if you write a program to do this, then run it until the optimal solution would have been found. Or if you then start having a decrease, then you know, okay, it's the max. But if it's the bit of a problem is you will have to kind of cut it short on iterations because remember, this could have looked like that other graph that we had in the way beginning that went like this up forever. So you'll be ascending for the rest of your life, and you're going to probably bomb out your computer or something. So you'll have to have some kind of break in there to say, okay, if this goes more than 200 iterations because it's a program, it's fine. Then let's assume to say it's going to go infinite up. There's no max there, right? But usually, if it changes so small, you can say that it's just steeply changing very small. So we'll conclude that that's close to the maximum there. But usually, it's very difficult to say if it's a max or just going on and on and on, right? So you'll continue searching until you realize that this is just going on and on and on. Right. Now, iteration 5 and iteration 6, I'm just going to open the Excel document there. So this one, I showed it there with fractions as well. So you'll see here in the fraction sheet that there's iteration 5 and iteration 6. All right, so you can go and check your answers there as well. H stays a half, then at least kind of you're in the right direction. It slowly increases, but like very, very slightly. Right, I also did it with decimal values, if you did it with decimal values, but I really do not like that because now you're rounding. So eventually you're continuously working with rounded values, which is not going to get the most accurate result. So I prefer not to do this. It's just if you work with fractions and we ask you to fill in the decimal places, then immediately, like as you work on this paper, you do it on assessment queue immediately by saying, okay, this is my answer for G of H. If that yeah, you've got two types of people. Someone will say it's me, and someone else will say, is it me you're looking for? Hello. Working. Everything is working. Just wanted to open. Hello. All right. Let me share my screen again. Let's see this one. Right. You should see my screen as well. Question mark. Okay, let's see. So that was it. We're just saying that the answers are there for you to check. I prefer using fractions. I do not like this because if you round, you're not going to get an accurate answer at the end. So please do fractions and then only fill in as you need to, right? So when you fill in, you can round, but obviously while you're doing the calculations, use fractions as far as possible. But that was it for that one. Let me see, where was the golden ratio? Let's see if there's something there. So you'll see if the golden ratio, it is purely the same steps except the function would have changed and your interval given to start with would be different, but the rest of it will be the same. Excel settings should be on radians. If you didn't change anything, it should be automatically on radians, but obviously it's a good idea to practice before the test and make sure that you get the same values, then you know it would be radians as well. For you to also double check is use a calculator, change your mode to rad, and then you know you're also working in radians, so that if you then quickly do, let's say, this to the power of 3 minus 6 to the power of whatever, and you do exactly the same thing on your calculator, you should get the same answer, and then at least you know whether it is the same thing. Right. Let me see. This one. Oh, okay. So if we wanted you to give it in terms of degrees instead, we're just saying that 1.047 radians is the same as 60 degrees. So any time that you want to convert it, you can take that final answer and times it with 180 over pi. That will give you the answer in degrees. Purely because they could have asked it in terms of degrees. But, I mean, you could have done the calculations in degrees from the beginning. However, because we're using Excel for golden section, you don't need to worry about that. But I would suggest that you just remember that if we wanted something in degrees, you would multiply it with 180 over pi. It's just to convert. If we wanted in radians, in degrees instead of radians, right? So it's just if we ask it for degrees, then you can convert, but not everything. We won't ask you to convert literally every single thing. That would be quite crazy. Let me see there. So that's the x value that we're working with. So the x value would be the angle. So that's why we're using the x value of 1.04, blah, 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 blah. And then that gives you an x value of 59.58. And then when you substitute that, let me just see what was the original equation. So where's that one? So 4 times sine of that 58, blah, 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 times 1 plus cos of that 58, blah, blah, blah. That's going to give you 5.19. So just to explain that part, sorry. So just to explain that part, let me just do this from current. Thank you for bringing this up. Let me just swap this. So just to show you here, if we ask you to convert, the function value is just the final answer after substituting. So your x value would have been, so if I write that 4 sine of theta, even though we said 4 sine of x, 1 plus cos of theta, we wrote it as x. So the x value is our theta. So our x value is the angle. So when you have to convert, you're purely looking at the final x value. So that would be that final x value that you're working with. Then you can convert that x value to degrees by multiplying with 180 over pi. That will convert it to degrees. Then once you have your answer there as, let me just say, 1.04162 180 over pi, that's going to give you a 59.68. Let me make it 4 significant figures, degrees instead, and then that you can substitute in there to get the function value. So your function of 59.68 degrees instead of radians now, because we won't ask you to convert everything, so probably the final answer only. Then that would be substituting literally that into your angle there. 1 plus cos of 59.68, and then you're going to get an answer of 5.195, blah, 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 blah. Right, I hope that helps. So the answers are correct. I'm just saying that is the answer of our x value. We convert that to degrees if we ask, of course. So maybe I gave you the x optimal and then I put a degree symbol there, meaning I want it in degrees. Or if, let's say in the original equation, you were not given pi, but something in terms of degrees instead, because pi would be radians. But if you were given something in degrees instead, then we will probably want it in degrees as well, right? So that's that. The 1.04 comes from the final answers, where you do that upper value, the last iteration x upper plus the last iteration x lower divided by 2 to get the middle. That's the optimal x value that we get. I'll just double check. Where's that one? So from this example, so you'll see the last lower and the last upper, you would plus them, divide by 2, that's in radians. Or to find it to degrees, I just round it, but in terms of degrees, you can be more specific to say that's 59 points. Now I can't remember what it was. 0.68 degrees. And then that would have been substituted in to get that. Not there. Let me see. I just rounded. Just rounded. This was the same, but just I don't know why it was rounded up though, but I would rather have said. Oh, I get what you're saying. That's probably just a typo there. So that should be blah 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 1.0416 blah 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 blah. That is, you are correct. Yeah, that's gonna be. Oh no. We were just saying what? Wait. No, it's correct. We're just saying 60 degrees is that. So this is close to the same. So it's close to 60 degrees. So that's specifically 10472. It's specifically for 60 degrees. Right, but our answer was 1.0416, meaning it will be close to 60 degrees, which is that 59.68. Right, just to say that if you knew what 60 degrees was in radians, you could have concluded that it's close to 60 degrees. Right, but very nice for picking that up. That's a very good observation. Okay, then for the rest on golden section search is purely just following that same, get the 0.6 of the square root upper, do the calculations, copy your formula down, and then every time you're just comparing the function values to see whether you're maximizing or minimizing. So if you're minimizing, you would do that whole equals min, and check between the two which one is the minimum. If you were maximizing, then you'll do max because you're trying to find the max z value. And I'm saying z value so that you realize we're looking at the f of x1 and f of x2 when we compare them, because we're looking at the z value. And then only when you realize which one will take you closer, you check which x value would it be that takes you closer. In this case, that would be x1. So then I use x1's value. So here in the interval, when you create your interval there on the side, you're using x1's value. So like we did with, do I have an example here? Like we did with these, where you make sure you use the correct x value. Right. Let me see. Yeah, that's about it. Let's do some of the review. Not going to save that. Let me remove this. Right. Okay, where's class S3? Let's see. Okay. So if you had struggled with filling something in, you learn from the review, right? Because we will keep asking in very similar ways when we get to the exam, right? Some things might change, but we will stick to similar ways. So learn from it, review to actually learn from it. We'll open hopefully today or tomorrow, but you'll get an announcement. So please, whoever sees that announcement first, let the others know so that people can go review, but it will be open somewhere today. Let's have a look. No, today. I mean, tomorrow you're writing, so it will be open somewhere today. Let's see. I should probably ask just to make sure. I'll ask that later, but it will be open today, don't worry. Let's see. So obviously you've got your instructions. Make sure you check what do they specify if a question itself does not specify. Okay, knapsack. So from knapsack, you would first create your IP from it. I mean, I think with the assignment, most of you are pretty tired of knapsack, but let's see. So for the IP itself, one of them will have a constraint. So we check there, it can only hold 25 tons of supplies. So the weight is the constraint. So only that amount of weight in terms of tons. So you know the worth will then be the objective. And if it's worth, you assume you're going to maximize that. Right, so that would literally be 920 for x1, 750 for x2. For the weights, it would be 13 for x1. So you're just putting the actual coefficient to the variable. Which variable? The items. So which items are going to be placed or not. So that's purely based on the IP. I'm not going to go through detail there. So you create your IP there. Then I didn't see any issues with this drop down, luckily, thank goodness. Then with this one, we now have to first get our ratio table because you can't start without it. Okay, so I'm going to just write the values. I do have the values here. I'm just going to zoom in a bit. So your ranking table from all your items. And just give me a second. Right, let's see. Okay, sorry, just wanted to ask about the review. So I just asked if we can open it soon, but it will be today still. Right, so from x1 to x2, x3, x4, those are our items based off of the order given. Then to get your ranking, so just remember you would do always your Z over your constraint value. So you'll see there's Z over constraint value. Please read the instructions. I mean, we gave the instructions there, please read. So for example, guys, if there's no instruction, then you use your logic and you fill in what you think it should be. But if there's an instruction, you have to follow it. So we said write non-integer values as fractions using this. So I don't want to see decimals. I mean, there's instructions saying write the values as fractions. So no decimals. Right, we even said use this, so it's quite clear. Don't simplify, because we want to see what was used. Right, so don't simplify. Don't say that 2 over 4 is 1 over 2. Don't simplify. Right, otherwise we won't necessarily see that you have the correct values that was left versus what was needed. Right. I see Miss Shemaine said she made an announcement about when it will be open. Cool. So we know at least it is there. Just go check. All right. So, not applicable if there's something where subproblems won't exist. If it's not a candidate, but not applicable in the Z-gap, because I mean, why would you calculate the Z if you're not going to have that as the placements for your items, because you're not even done branching it? So something like not applicable or calculating it with a fraction would have also made sense, but obviously we specified here, not applicable. Right, for the assignment, we consider obviously anything that makes sense. Right, for if it's infeasible, then you please have to write infeasible, where in the Z-gap, and then some things might have been left out, right? So let's see. Ratio test. So you saw now, remember, it is the Z over the constraint. Right, so for each of them you do that and you leave it as fractions. So if you wanted to go and change it to a fraction, you can literally go and change it to a fraction. You can then just go to more options and change the type of fraction if that was something you struggled with, but that would have been still accepted because we didn't specify. But yeah, technically you would have written 920 over 13, 750 over 5, 580 over 12, right. So then you rank it from largest to smallest because you are trying to maximize. If it was minimized, you would do the opposite. So that would be the only difference. And then obviously your sign would have been different if it was a min problem. And then your checks would have been just the other way around. Okay, but starting from there, so even though we list it like this, you still have to know how to do the algorithm, right? So we go on, we say, okay, which one is first? This one. That's x2, so we place x2 first. So x2 is placed. Then from the amount that we have available, we subtract the amount that x2 will use, and then we're left with a 20. Now we check, okay, that one's complete. Okay, now the next one. In our ranking table, the next one we look at is x1. Then we say x1 requires 13 weights, tons. Then we check out of 20, yeah, there's still 20 left, so we can place x1. So out of the 20 that's left, we place the x1, and then we left it for 13 there. And I told you in class, these values are your own calculations. That's not what we want you to fill in because that doesn't represent whether the item gets placed or not. These are your own calculations for checking if you can place it or not. Right. So then we place it, we're happy, x1 is in, right? Now we check again, we say the next one is going to be x4, right? x4 requires value of 9, but from my last item that I placed, I had only 7 left. So then it's going to be that whole fraction of, so you don't write the decimal, the fraction of 7 over 9. So always the what's left over what you require to get a fraction between 0 and 1. All right, so that it clearly defines that you can either go to 0 or 1. Okay, then because you never even looked at x3, x3 is automatically 0. All right, because it's not going to be placed. Now from there, you have your subproblems x4 equals either going to be a 0 or it's going to be a 1. Right, so we go and check those. So now we do the exact same, but we make sure that x4 was done first. So in this one, x4 is 0, so there's no checking what's left. I mean, it's not placed at all. Now I go back to my ranking table. So my ranking table, I check, okay, what's next? Okay, first item on my list is x2. So I go and try to place x2. So x2 is placed, is that whole, okay, out of 25, x2 uses 5, so 20 is left. Okay, x2 is placed. Now out of 20, I go check again my table. I just didn't do it again because I mean, it's the same as the previous. But you then go check x1, you'll see there it requires 13. Okay, out of 20, I do have enough, so I subtract that 13, I have 7 left. Okay, x4 is definitely 0, so I go to the next, and that's now x3. x3 requires 12. I only have 7 left, so the value is going to be 7 over 12. All right, so literally 7 over 12, because we asked for fractions. Right, now you could decide, are you going to do it on the same side or first branch down and come back later? Up to you. I'll do it on the same side and say let's do the same thing, but here we're placing x4 equals 1, definitely. Right, so x4 equals 1 there. So we immediately go and say x4 requires 9. So out of 25, what's left? So 25 minus 9, you'll get 16 left. Okay, now we go back to our ranking table. What's first in our ranking table? x2. x2 needs 5. Okay, I have 16 left, so 5 can be used. Perfect. Now out of that 16 left, I subtract the 5 to see how much is left. So remember, this is all that's just left. Now I go back to my ranking table. The next item on my list or rank is x1 with 13. But I only have 11 left, so not enough. So 11 over 13 is my fractional value. x3 was never looked at, so that's 0. All right, so for this one, you're going to branch on x1 and make x1 either 0 or 1. All right, so from that one, you'll see x1 is made either 0 or 1, but you had to remember that whatever was forced before, keep on forcing it from that branch. That's why I put the colors there. Keep on forcing it. But now x1 is 0 or 1. Right, on this side, we were forcing x3 to be 0 or 1, where it comes from a branch where x4 is 0. So x4 is 0 on both, but you're checking x3 equals 0 or 1 between the two problems. All right, so I'm not going to go too deep on that. Just this one would have been a candidate because there would have been, after you would have had both of these zeros, you could place both x1 as well as x2 without exceeding your limitation of that 25 tons. So meaning you have a candidate and you would take x1 and x2's worth, which is 920 plus 750 to get your Z value of that one. Right, on the other side of it, you would have seen that it forced you to branch another one because you didn't have enough left. So 8 left, but you need 13, so not enough. You've got a fraction. So that one would have continued to branch. Now just take note. This problem comes from this problem where x4 is equals to 0. So x4 stays equals to 0. I'm just highlighting that. Now it comes from a branch where we made x3 equals to 1, so x3 stays 1 because it comes from that branch. The only new thing is going to be x1. That's going to be either 0 or 1. Right, both of them would have worked out to be candidates. Right, let's go to the other side. Now I'm not going to show you everything, but when we get to, let's say, for example, this one, you were branching from a previous branch where x1 was already 1 from the previous branch and x4 was already 1 from the previous branch, and now you're checking to force x2 to be 1. If you place all of those, it will exceed the amount of tons that you actually have available. So immediately you say it's infeasible because you're forcing it to actually happen. Right. Okay, so it's notified your test is open from 12. Right. Okay, I just wanted to confirm. All right, so that is the knapsack. So you're literally just doing it like you used to do. I'm not going to go through too deep, and it's not too difficult. So you'll see there from 0, and then you had to make 1 0 and 1 1, and then you just have to name yours the same so that you can follow the same. Same there. Make this one 0, make this one 1. You do the same numbering so that you can follow the same. If it didn't exist, you put not applicable, although they all existed, sadly. Do the same, fill in. Obviously, you'll be able to review and go check it, but yeah, that's pretty much it. Branching, following the question numbers. Right, at the end, you would then have to specify which one is the best. So out of all of them, you would go back to the best one, which was sadly one of the first ones you found. And that one would be this one. All right. I don't think it matters what question type was asked. It's just what we went with. And to make it quite less obvious, if I put a drop down there, then you know it's either 0 or 1. And I want to know that you know it's either 0 or 1 because some people don't. Just to make it clear. Some people don't even know it's 0 or 1 and they put random values in there. So yeah, I'm not putting drop downs for this. But yeah, that's my reason. I don't know what the reason for anyone else, but that's my reason. Sadly, you should know what you're doing. So yeah, there's no mercy, unfortunately, for that. We already give you a lot of stuff like the numbering. 1 should be 0 or 1. So I mean, there's already some guidance there to say 1 should be 0 or 1 instead of 13 and 20, for example. So there's already guidance that could have been nowhere, right? But yeah, follow instructions, no mercy. Right. I used to tell the face-to-face students as well, remember there was a time when people had to do this on paper with no guidance, like none. You get the question and that's it. So if you decided to use branch and bound simplex, shame, 0 for the whole question. So appreciate what you have and rather not complain, you know. I know it's sometimes difficult to fill in, but you have some guidance, appreciate the guidance, right? Might not always be easy because we try to not make it too obvious, but yeah, I think that was rough. The time without assessment queue was, I think, a bit more rough than now, especially with LPR 381. Because imagine one. It's crazy. Right. Yeah. And imagine if you did branch and bound simplex for this, but you should have just done the knapsack method. Imagine that. Wasting your time for the whole test on branch and bound simplex, but that's not what we asked. That would be a big ouch. Right. But yeah, feedback's always welcome. Just saying in that case, nah, no mercy. I'm sorry. I'm not going to make it more obvious than it already is, to be honest. Right. So please, you know what you do in class, follow the same, right? You know what you do, follow the same. So please do the exercises and check your answers in detail. Don't just go and be like, oh, my final answer is correct. It's not necessarily about the final answer. I have said this before. It's about the process as well. So knowing exactly what to take in terms of steps, step by step. You can't skip steps. It's an algorithm. You can't just skip a step. What are the checks? Every single thing needs to be done. All right. So just to make it clear. But yeah, of course, you can go do that again, like literally for studying purposes, like write down the question, redo it from start. I might rather say redo it before an exam again, maybe as practice. We're not opening it again. Don't ask me. I'm saying for your own. I don't know what you do at home. But anyway, obviously, keep your notes, especially for tomorrow's test. Whatever you do on paper, so that you can, when you review, it's easier to take note of if something was maybe by accident marked wrong, or you wrote it differently, but there's no instruction and it's still correct, things like that. Because with algebra, there's quite, you saw when you did steepest ascent. I mean, if I ask you to fill in something with an X and a Y, you could have swapped the X and the Y around if I didn't say how you should write it. So please write, when you do the test, keep your notes so that you can check afterwards. Right. But please go through the test. For tests, no, you have to contact the person responsible if you find something, and then send screenshots. I think this time it was Charmaine made the post, Miss Charmaine, so you can contact her. For the assignment, yeah, we mark that. If we don't open it for review, we mark. Right, and biltong. I don't know if Miss Charmaine will like the biltong, though. You might need to fish around and find out what to send along. But yeah, please review. For the assignment, because we don't open it, we definitely mark detailed. So don't worry about that. But for this, please, if you pick something up, ask. But please don't ask if there's an instruction. You're just going to annoy someone. To be honest, Armando, I'm not so sure though. Is there anyone in class that would disagree with that statement? Curious. Although I like biltong, but I won't say it's my favorite. So I prefer something else instead. But yeah. Anika. That's their face right now. So classic. That face was not like the perfect. Leonard, really. Now we know that's a dead giveaway. Yeah, I would rather take a cupcake or something than in biltong, to be honest, you know. But yeah. Armando, sis. No, sis. It's quite funny that we can always laugh about every single thing, even if it offends us as well. Hey, South Africans, you guys. But you made my day. Yeah, for me that's a great event, definitely. Yeah, but it has to be a very delicious one. I'm not gonna put on fat for no reason, you know. Success. Let's see. The due date's still the same, but the cutoff is changed. The cutoff date, so you can still submit after the due date. You won't be penalized. Unless if you were a full group of 4 and you were just misusing it. No, I'm just kidding. The extension is for everyone. So if you need it, use it. If you feel like you are finished, you are finished. Right. No problem. You guys are funny today. Let me see before I get too distracted there. It was a nice conversation. Let's go on there. So true. So true. I can't argue that one. I won't say if I am the same type of person though, but that would be a compliment to anyone that enjoys both. Because being weird is a good thing. Or I see it as a good thing. All right, so let me see, to go back in this. Let me see, for the machine scheduling, I did warn you to do the whole thing before you start filling it in, because you need to be able to do the algorithm like it should have been done, and then you fill in whatever we require. If you followed on assessment queue, you probably would have just done what was needed and not gotten the right answers. You need to know the algorithm and be able to do it fully and then fill in. Please, please, please take my advice again. Right. Wow. I assume you guys were face to face at some time. You guys were like, oh, okay, so that's where the comments come in. We'll have to ask for Caitlin to do a virtual courier party, something, you know. Oh, crazy. Crazy. Let's see. So XI job, that's the usual. So if this one, let me see. So there's a penalty. So penalties involved. So you have to do the penalty as well. Although they do say minimize the total hours due to delayed. So total hours of torture, meaning the penalties. Right. Yeah, I would love to join there, but yeah, I don't know. You guys are online, probably only attend at Pretoria, which would be sad. I'll watch you online, and then I'll miss my virtual sour worms. It's fine. Armand Resis. Okay, let me go on. I think that was a good answer. Okay, so you're minimizing the penalty there. Let's see, you've got your penalties, your different items, or in this case, jobs, the time required, your due date, and then in the first table, we just wanted to see in each problem which variable were you referring to, so which job and which position, and then the total penalty for each of those. So I'm not going to do it slowly, so I'll just show you here if you were to do it. The whole step was to create this table or do it on paper. It's up to you. Then it would have been job 1, 2, 3, 4, because those are the jobs available, and you start in the last position. Right, so all of them end with 4 because it's trying to put it in the last position. If it's in the last position, including the job that you're checking, all the jobs would have been done at that stage. So the time required would have been all of them added together. Then checking how much this specific job would be over its due date, you would subtract that specific due date from the total time required for completing all the jobs at the last position, because it's the last position. Right, after that, you times it with your penalty for that specific job, and then you don't have a total penalty yet due to the fact that it's your first problem, your first position that you're doing. Right, so you would not have all of this yet, so I'm just going to quickly just make it like this. Right, so you wouldn't have that yet. So you do that for each of them. That's not specifically job 2's due date and job 2's penalty. That's specifically job 3's due date and job 3's penalty, etc., etc. Anika, yeah, that's a good tip. I also did that previously when I set up tests, but I was like, yeah, let me not confuse anyone. But yeah, if you figure it out, do it. Please, please, please use your locking of cells and drag it the correct way, know how it drags, then that helps so much. All right, so to make it clear, because most of you will now ask about the next. So you'll see there we go with this one. So it doesn't matter what I ask, you have to go with the smallest one. Otherwise, you'll end up branching everything, which is definitely not what the algorithm is doing. Right, so you pick the smallest one, would have been the 54. So problem 2 would have been your starting place, which you should have branched first. Right, now you break it down into 2.1, 2.2, 2.3. The job that was placed was X24, meaning job 2 in position 4. So the jobs that are left are jobs 1, 3, and 4. So you'll see job 1, 3, and 4. The next position is position 3. Right, then you do the same thing. Now it's job 1, 3, and 4. So when you add the time required, it's 1, 3, and 4. This one is checking the due date for job 1. So you subtract the due date for job 1 and multiply the penalty for job 1. This one is for job 3 due date, penalty for job 3. This one is job 4's due date, penalty for job 4. Now, if you didn't do the next step, you would have also had some problems because you're minimizing the total, not the current penalty, the total penalty, meaning all of them together. So you had to actually then go and add the previous penalty as well. So you'll see here, that penalty was 54. So you would have actually had to add that to the penalty for each and every one of them. Okay, now from them, you check which one's the smallest. So that would have been this one. So you wouldn't have had all of this yet. So it would have been this one. Right. Then you would have gone down and said that one branches into these two. Right. Which jobs? Okay, let's see. It comes from problem 2, which was job 2 in position 4. Then it was job 4, position 3. So job 2, job 4, done. So the ones that are left is job 1 and 3. And we're now in position 2. Right, so it's job 1 and 3 that you go add. You do that whole subtraction, add to the previous, only the previous, not all. You already added the previous. So only the previous one you add. Okay, we start seeing that we might have alternatives. So you pick the one, you branch, you get your candidate. Then you go and say that this one next to it is the same. So if it's equals, you also branch and you get your alternative there. Right, now that doesn't mean you're done. It really doesn't mean you're done. Just to explain the alternatives, so I put the values here so that you can see them. That's great. So if you put it there, then you'll go back and say, what does this mean? So X31 means job 3 done first. X12 means job 1 done second. So 3.1 comes from this branch. Just to make it clear, it's actually this one. Job 4 done third. Job 2 done fourth, and you just had to match it with the correct job. Right. Alternative, you'll see there it was the same, the same starting jobs in the starting, well, not the starting position, but the ones that you started to branch with. So the last and the third position. Then the other two were swapped around. Right, but the candidate has the same Z value. Candidate, so it's an alternative. Right, so there we go. Then you would now go and eliminate. So now you smile because now you can start eliminating. So you work step by step backwards. So when we get to this step where we were now coming from, 89 is better than both of these, so you would have now added this eliminated by candidate A for both of these. Right, I'm not there yet, just both of these. Go one back up, you'll see this one would have been eliminated because that is not less than 89. However, this would have still been less than, so not eliminated by candidate A, but candidate B, meaning we still had to branch, hey? So we had to branch now with problem 4, because that was the next smallest between 77 and 55. So you would have now gone with 4.1, 4.2, 4.3. Okay, you do that whole thing of this was job 4 and position 4. So I have job 1, 2, and 3 left. Position 3. Then I go add job 1, 2, and 3, the actual time required for them. Then I check specifically this one's job 1, so I subtract for job 1, I multiply for job 1, this one's for job 2, I subtract for job 2 and multiply for job 2, and etc. Then I add the previous penalty. Okay. Now immediately I realize that none of these, sadly, are bigger than my candidate A. So right now, none of them was actually eliminated, sadly. Right, it's only later on, so I'll make it yellow for now. It's only later on, right? Because your candidate A is 89. Candidate A is 89. So they're all smaller. Which one do I go with? The smallest one. So 4.2. That would have been your next step. Right, so 4.2.1 and 4.2.2, you branch from those. Okay, I already see some zeros, so I'm like, probably alternatives. But let's see if it's better than candidate A. Right, get to this stage, 61, I smile, I get something better. So I get my candidate B, I go back, I do this one, I get my alternative. Right, so I have a candidate and I have an alternative, which is better than candidate A. So you should have technically eliminated these as well because candidate A is not the best anymore. It's now 61. So now when you go back, now these are actually eliminated because this is bigger than 61, this is bigger than 61. Candidate B eliminates those. Go back one more, candidate B eliminates that one, and we branched everything and eliminated whatever was not branched. So we are done. So going back here, you'll obviously be able to see the solutions and whatnot, but obviously you'll see there which problems should be branched first. So that would have been problem 2 because that's where we started branching with the smallest one. Then we asked you to fill in all the branches below. So meaning you had to go and do the whole algorithm, but use NA for branches that were eliminated previously. So if I go back here, that one was eliminated previously. That one was eliminated previously. So you should have said not applicable because you never branched those. Never. As you can see here, it's problem 2 and problem 4 that was branched. But those were eliminated, so they shouldn't have been branched. So those should have been not applicable, not applicable, not applicable, blah, 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 blah. Right. Then from there, we just wanted to know, based on the algorithm, which problem should have been branched first when moving to the next position. And I gave you the hint there. Only consider the one that you branched first, just to help you there. So that would have been then from this stage now, where you check, okay, 2.3 would have been the next one we went with. Right, and then I stopped doing asking that type of questions because otherwise it's going to get too confusing. So I then just immediately a penalty for the alternative, which would have been the same value. Alternative of that would have been the same value for B and alternative for B. And then you had to fill in the correct jobs at the correct places. Right, so just to make it clear what I mean with jobs at the correct places, so just going back here again, X31 means job 3. Which job is that? Job 3, so I go back to my table. What was that? So in the beginning, writing it down helps. Job 3 was memory core. Job 1 was neural processor. Job 2 was chassis. Job 3 was memory core. Assassination algorithms was job 4. So that would have been what you fill in. So just going back down here, so you'll see, for example, this one, X12 refers to job 1 in position 2. So job 1 was done second. Job 1 is neural processing. Job 2 was done third. That one. Job 4 was done fourth. That one. All right, so just to make it clear, that's what we're referring to. All right. Okay, and then to see that you did the algorithm completely correct, we wanted to see what eliminated what. So from there, you would have seen that we said only consider branched. So you'll see they do not consider those that were not supposed to be branched, because that would be quite pointless. I mean, if you didn't have something that, let's say problem 3.2, that didn't exist. So how can you eliminate something that you shouldn't even have? Right, so we were trying to hint towards that so that we don't give away the answers. Hey, otherwise it's too obvious. Don't ask me about that. It's too obvious. I'm not going to give away the answers. Sometimes I do, and then you smile. Right, so these two, for example, even though that was supposed to be 3.1, it's still something that shouldn't have existed. So you shouldn't have touched these two at all. Right. Which problems were eliminated by A and B respectively? So we wanted to make sure that you have done it the correct order, eliminated what should have been eliminated. So going back here, it's literally you going back and said, problem 1 was eliminated by CB. Problem 3 was eliminated by candidate A. This one is candidate A, this one's candidate A, this one's candidate B. If you followed the steps correctly, you would have had that already. If we went further, then you would have said these as well. All right. So you're literally telling me what was eliminated, what was not eliminated. Right. Well, Andre, I could have seen exactly that you know how to do the branch bound method if you were able to answer this. So it does test the algorithm. It's just if you didn't read, then you miss marks based off of not following instructions, right? But yeah, like I said before, it's horrible sometimes, but it's still better than nothing. It's still better than getting no guidance at all, right? But yeah, we don't play with your life. No, that's very dramatic, Andre. Very dramatic. Such drama. Okay, let's see. Question 3. To make up for question 2, which is hard, I put something that was basically an exercise. So if you actually did the exercise and checked the solutions, you would have been quite perfectly fine with this one. Right, so yeah, that was to make up for it a little bit. Let's see. Yeah, please follow that instruction about not using the black theme at all. I think we gave it in the exams because we said that sometimes it does that, and we've been asking for it to change, but yeah, sadly, that's what we're living with. Right. Andre. Right, for this one, so obviously just check your answers. I'm not going to go through it again though, because it's very much the same as the exercise. However, if I get to this, we know about the issues, but it did mark it correct in the end. But obviously check the solution. I hope you guys wrote stuff down, but some blocks will be missing, but it did mark whatever was in that block before it disappeared. We tested it multiple times. So it did mark correct. It's just you won't see necessarily what you put in, but I can tell you now it did mark correct. It's just terrible not to see what you actually put in that block, sadly. Right, so yeah, I did mark it correct. It just didn't show it. Right, so yeah, and some of you sent me privately, and I also went to check that it actually had those in, that the green ones were actually the correct ones and stuff like that, right? And for those of you who haven't checked, I have sent through to Miss Charmaine to also have a look if I didn't check all of them, because she's the one checking this test. Okay, we did avoid the same issue with the next test. So we picked up the issue, we have reported the issue, and we avoided using the same thing for the next test to not have the same problem. Right, it only happens because of some drag and drop options being used for different blocks. So that kind of glitched. So when you reused something, it didn't keep that block there, even though it is still there. It just didn't see that block anymore if you clicked somewhere else. But it was still there. It just didn't see it, sadly. Right. Yeah. So yeah, you saw that you had to probably drag from the same block or from the question itself. You have to search or reset it. Yeah, so I tried to give you some advice during the test there. If I see something, I'll always help. All right. But yeah, it's on the exercise, based on the exercises, literally also on warehouses. So you can go back to that to go and double check how did that work, which we also did in class. Right. I don't think anything else is necessary. But please, 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 if you pick up something, do not just leave it. Rather send a screenshot and ask. It doesn't hurt to ask, unless if it's something that's explicitly stated and you're just asking because you want to try your luck, then yeah, you're going to probably annoy someone. Please don't do that, right? But yeah, if you pick something up, marked incorrectly, there's no instruction, please ask, right? Then we can always check. So guys, obviously tomorrow is a test. So I will be giving you instructions and so on, but we won't really talk tomorrow. So I just want to make it clear that we will announce to you when the test will be open for review. And I will, lately it's better to keep it on the same, like also Wednesday, so that you know what to expect. So it's going to be somewhere around Wednesday. So I'll keep it Wednesday, it will be open. So either Wednesday morning I'll send an announcement, or Tuesday night, or Mr. Chetini might also actually send it because he's also on that test, but one of us will then give you information with regards to when it will be open and who to contact for what. Right, so please help others as well. If you see an announcement, let the others know, because not everyone has a mobile app, for example. Please, help each other out, please. All right. But yeah, that's it from me. I think we went through all of this. So is there any questions based off of this that you want to see? Like just something that you want to see based on my memo, maybe something you wanted to just look at? Let me know. Now's your chance. Armando, you're very quick on your comments. Sorry now. Yeah, you're on your own. I'm sorry. Oh, thank you, Annika. It's a very pleasure, and it's so nice to see comments like that. Yeah, always if we see comments like that, it really makes a difference. I appreciate. I really do. It's always bad to be a lecturer for a very difficult subject, but yeah, I really appreciate the comments. Really. But yeah, please ask if there's something now while there's a chance. But guys, if you have no question, then obviously I'll see you for the test tomorrow. And good luck. Remember your webcam and all that. Don't have issues tomorrow. We don't want you to lose marks. The summative counts a lot. You know that. Okay, please, it counts a lot. Work hard, please, please, please. And I'm gonna miss you guys as well. I'll see you guys tomorrow for the test, and then good luck. I'll see you then again.